Would someone be so kind as to tell me the title for section 7.5? See if you guys paid attention. Parts of similar triangles. Okay. Let's say I've got two similar triangles here. So I'll draw yourself two nice big similar triangles that we can label a little bit. We've got two sets of similar triangles. Have you checked in with the office, or did you just get here? Okay. Now, let's make the sides here x, this side x, and this side y. This side A, and this side B. This side S, and this side T. What do we know is true if these two are similar? X over Y is equal to what? S over T, which is also equal to what? Would everyone agree that we know that to be the case? You know that they're all said to be proportional. Do you guys remember that what are the perimeters are also what? Proportional. So that's another special part that's actually also proportional and equals the same scale factor. Do you guys understand what we say when we're saying this is proportional to this? Because if you don't, when I'm explaining this, you're just going to you're not going to understand what in the world I'm talking about. When I say these are proportional, their ratios are equal, and when I say the perimeters are proportional, well, basically, how do you find the perimeter? Well, it'd be x plus a plus what? S over y plus b plus t, right? I'm actually saying that ratio is also equal to that one. That when you add those up, it turns out that that'll equal the same fraction. Okay? So we're saying they're proportional to this same scale factor. There are parts of a triangle that are also proportional. Altitudes are proportional. What are altitudes? What is an example of an altitude? You guys remember what those are? They tell how high the third point is. For instance, if A is the ground, right? You can draw three different altitudes here. The altitude would come from what? Here, right? And it would make a 90-degree angle. Does everyone agree? And here, the corresponding altitude would be what? This one right here. That being 90 degrees. So what am I saying? That I could add also to what? That this over this is the same scale factor, isn't it? So that's what we're saying. Does everybody understand that? Now it has to be a corresponding altitude. It can't be the altitude for this one and then this altitude. Does that make sense? It has to be at the same place, in the same location. And this might make more sense when we do the examples. So, in fact, let's do that. Now that we're talking about altitude, let's hop over to a problem from our red book, and we'll hop back over to here. And let's do a problem that has altitudes in it. Well, how about number 1 on page 91? This has altitude, doesn't it? Isn't that what each of these are? This an altitude? So, by the concept we're talking about, what proportion could I set up? Well, this whole side here is what? And this whole side's what? 10.5? So the ratio of the sides, so 14 over 10.5 would equal, well, I said that the altitudes are proportional as well, correct? Guys, right now, let's just watch. So, what is this? 14 over 10.5 would equal what? Because they're in that mix too. Cross multiply, 14x is equal to 231. Divide by 14. What do you get? I think 16.5. But do you see that how I'm talking about that the altitudes are proportional as well? Right? Okay. You know what else is proportional? We have a third thing. Other parts or things that have the same proportion. That is angle bisectors are proportional. Let's look at number 1 on page 92. Why do I say this one? Because what do we have here? What is happening here? It's an angle bisector. It's being cut in half. And it's also, well, maybe not. No, I take that back. It's not. Let's go to number 4. No, that's actually not what I'm looking for here. Well, then I'll just have to make an example. Don't you hate it when that happens? Huh? Because it's actually an altitude. Actually, what they're saying here is that that whole angle is congruent. What they're saying is that whole angle is congruent to this side. They're not splitting it up. Does that make sense? They're saying this whole angle is congruent to this whole angle. And see, then I saw this and I was like, oh, that's an altitude. And as you can see, if you look at it, it's not cutting it in half, is it? Okay, so I will make an example of our own. And you can just, guys don't have to write this down. So an angle bisector, you have it like here where it perfectly what? Cuts it in half, correct? Let's say I had another one here where this perfectly cuts this in half. And like I said, you don't have to write this down. So let's say this was x, this was 10, this was 5, and this was 15. What proportion would I set up? And you see how the angle bisectors have the same proportion, so it would be 5x is equal to 150. Divide by 5. X is equal to what? 30. If you want to write that down, you can. I'll leave it up there for a second. But that's a instance where we used angle bisectors. But isn't it just the exact same type of problem we've been doing? It's just we're adding some segments that happen to also have the same proportion. We ready to go on to the next one? The last one. The medians are also what? Proportional. Well, now let's go to number 2. Look at number 2. Why are those medians? You guys remember what medians are? They go from a vertex to the opposite side's midpoint. So that's why these two are what? Medians. So what would my proportion be? 33 over x equals what? Okay, or 15 over 10 equals 33 over x, right? Cross multiply, what's going to happen? What are you going to get? 15x is equal to 330. Divide both sides by 15, you get what? 22. This isn't too bad, is it? Okay. Once you understand what you're doing. The last thing, though, and it's not, this isn't, it has nothing to do with similar triangles. This has to do with triangle in general. So I would appreciate if you guys would just pay attention here, because this is really easy once you get it. But I would hate for you not to get it because you're so worried about writing it down that you don't get it. Okay, let's say you've got this triangle. How about I bisect this angle right here? So let's measure it. What's the measurement of this angle? Was it 68? So that means bisecting it would be 30 what? 4? So I'm going to draw an angle bisector. A special thing inside this triangle actually happens. Probably something you would have never guessed. Isn't that interesting? What did this angle bisector do? It kind of separated into two triangles, right? Actually, what I want you to look at is first, when it came over here and it hit this opposite side here, it cut this side into two separate parts, did it not? Two separate pieces. Well, an interesting thing happens. These pieces are proportional, created. What I mean by that is this, let's make this X, this Y, make this S, and make this T. Okay? What do you think I mean when I say those parts created are proportional? X over, what is the side that goes with it? The part that goes with X, the one on its side? S is equal to, what do you think is going to go on top over here? And what is the part on its side? That works out every time. Interesting, huh?
Yeah, that's pretty interesting.
Anytime you draw an angle bisector inside of a triangle, that proportion, it breaks it up proportionally. Let's write that down. an example to go with that. Look down at number 7 on page 91. Tell me the proportion I'm going to set up here.
26 over 12 is equal to 10 over 8.
See how easy that is? Is it 208? What do you get M to be? Repeating? So 17 and a third. It's not too terrible, is it? You guys get the concept of the things we're doing in this section? All right. Hey, well then you have graduated to being able to do numbers 1 through 24. Write problems, draw the figures, and show all steps and work. And it is due the end of the hour, mañana, tomorrow.
I thought you said Monday for a second.
Doesn't mañana mean tomorrow? That's what I thought.
But it sounded like you said
Oh, I got you. Well, I'm not the best with that kind of stuff. I thought I might have said that. I might have thought that meant tomorrow, but it meant something else. So I was checking myself. Okay. Luckily, because we rolled through that,